All right, good evening, good morning, or good afternoon, ladies and gentlemen, and welcome. Today we're talking about lesson 1.7, which is functions. This lesson is actually kind of a long lesson. There are a bunch of different examples, so I'm going to teach this over a day and a half. So if you miss half the lesson, please make sure you come watch the video to cover the other half. So let's get started. Today we make sure you guys have your books open to page 49 is the main part of the page that we're covering today. It starts at 49 and it goes on for a couple pages. So, and the bell work, make sure you guys put down that this is lesson 1.7, and also make sure you just put me the annotation on here with the number of the questions, okay? In class, we had about a minute each to go over these, and then I put the slide forward, so please answer these appropriately. All right, so on this one, the easiest way to do it, remember, is a kind of a correlation. Which expression expresses the relation of -1, and it gives you all the points. So if we go along the line here, because I see these two are different. -1 and 0 is the first point, and that's actually on both of them. Okay. Then this the next point is 2, -4. So I see 2, -4. I see 2, 2. So ladies and gentlemen, right away you know that this is not one of them. So we have a combination between these two. So let's begin again. -1, 0. That points to there. We already know that one is. The next one is 2, -4. That's on point. -3, 1. -3, 1. -3, 3. That is not it. The only answer can be a C. Process of elimination. Okay. Make sure you guys do that in every assessment going forward. All right. Number 3. Check this out and let me know what you think. Oh, let me give you the last example just in case. All right, student earns $8 for every lawn he mows. Which equation represents the relationship between the amount of lawns mowed, L, and the wages earned, D? So what do you think that would be? Okay, if he is mowing every time he mows a lawn, and how would you actually represent that in annotation? Well, if you're doing it, it's not going to be addition, okay, or subtraction. That's just idiotic. So it's either one of these two, okay? And through the process of elimination, we're talking about how many times he does what? The total wages, or how many times he mows the grass? And it's this, how many times he mows the grass, so it's actually D. All right, process of elimination. Jason, a waiter, gets his tips. He expresses it on a chart, okay? And the relation, let me know which one is correct. All right, this one's pretty simple, ladies and gentlemen. When you look at it, your first point is 10, 2. Where's the only table that is 10, 2? 10, 1.2, no, and no. So please make sure you guys understand at a table, okay, that this is it. I don't want you guys, when we're doing these assessments, remember sometimes on the CBAS, we talked about this, and I haven't talked about it to you yet, but what's going to happen is you're going to be given a short amount of time. Last year when we did our final, we had 60 questions in a matter of, or 40 questions in a matter of 60 minutes. Ladies and gentlemen, it broke down to 2.5 minutes a question, okay? And when you thought about it, it was actually closer to 1.5 minutes. So you got to move quickly, all right? And so this is the one thing I'm going to do in class this year is teach you how to take a test as well. All right, mathematical practices. We're going to construct viable arguments. These are the standards that we're covering, okay? If you guys have any questions on these, let me know, and we'll go from there. But that's the standard that we're covering. You have been able to solve equations with elements from a replacement set. What that means is if I tell you to replace something in, all right, or substitute something into an equation, you've been able to do it, right? So, for example, if I say n equals 11, like we had, and I say 4n, how would you actually interpret that? This would be 4 times 11. You're substituting this into here, okay? That's how you would do it, all right? That is what they're talking about. Now you're going to determine whether a relation is a function, and then you're going to start graphing linear equations. Linear equations basically means lines. All right, in your vocabulary on page 49, you're going to start running into this. The first word you're going to run into is what a function is. All right, then if you flip the book, go ahead and flip your page to 50 and then 51. It talks about a discrete function, what a discrete function is, and what a continuous function is. Discrete consists of points that are not connected, and connected. You will be tested on these two, ladies and gentlemen, and I'll have to have you know what the difference is between them. So make sure you annotate this in your mind somewhere, these two at a good enough point. Vertical line test. is the test that I will ask you guys to do every time we have a function, okay? Where it is you have a vertical, if you have a line or a linear equation of some sort, the best way to find out if it's a function is does it pass a vertical line test, which means if you draw a vertical line through it and it only crosses it one time, it's a function. If at any point it crosses it twice, it is not a function, ladies and gentlemen. And then we'll talk about function notation and nonlinear functions. All right. So if you flip back to page 50 or page 49, we start to talk about this, okay? This is on your notes. A function is a relation in which each element of a domain is paired with exactly one element of a range, okay? So for every one domain, there has to be one range, all right? Now, what that means, ladies and gentlemen, is can you have one, we'll talk about it. And it goes, if you were to plot these points out, as we move along, I'll show you the difference. So what it means is that for every one value of x, you have one value of y. Okay, that is key. You can have multiple values of y to the x, but not x to y, and I'll show you that in a little bit. All right, so determine whether the relation is a function. Explain. So for every one domain, you have one range. Is this a function? Yes, it is. The reason is if you were to plot this out, okay, on a point. So if I go -2, 8, so I'm not going to point the whole process here. -2 over, -8 down. Let's just say there's a point way down here. And then 0, 0 is the origin. Change colors. Okay, and then 2, 8, so 2 over 8 up, so you got something way up here. And then 4, 16, so you got 4 over 16 up. You're way up here. Do any of these actually, if you do what's called the vertical line test, so if I draw a straight line through any of these points, this point right here, -2, -8, does it cross another point? No, it only hits one point that we're looking for, so it is a function, okay? Now, determine whether the relation is a function. Now, this is the same process, okay? -7, -4, -2, 3, 0. Whether or not that is a function, it's the same setup, okay? What you're doing is it a function? You can graph it out as well. So you go -7 over, so if I did it again, change the colors. If I went -7 over, -12 down, somewhere down here, -4, -9, 2, 3, and 5 over 0. Is that a function? Yes, it is. Okay? Determine whether the relation is a function. It is a function. Why? Because it passes the vertical line test. Okay? Make sure you guys understand that. If you guys look at page 49, it talks about why it is a function. Okay? If it has only one domain. Now, and make sure it's understandable. All right? Look at your guys' examples and it'll be good to go. All right, so let's talk about this guided practice. Is this a function? Okay, you guys look at it. Let me know what you think, and we'll go from there. Is this a function? The answer is yes. Okay, for every one domain, you have one range. Is this a function? Okay, for every domain, you have one range. Is it a function? Letter B. The answer is, let's plot it out. And let's see. So I'm going 3 over, okay, 2 up. So let me do the little tick marks on this one, okay. All right, so let's plot this out, shall we? All right, if I go 3 over and 2 up, I have a point right here. 1 over, all right, -2 down, point here. 2 over, -4, so if I go over 2, down -4, so I have one right here. And then over 3, -1 down. All right, so the question is, ladies and gentlemen, is this a function? Well, if I do the vertical line test and I draw a straight line, how many points does this cross? It crosses 2. So, is this a function? The answer is no, it is not. And the reason is, remember, for every one domain, you have to have a different, it has to be different domains. Okay, remember, it has to be one domain to a range. So you have to understand that when you're crossing these out, if you have the same domain coming over here, you cannot do it. Now, say for example, if I were to process this out, all right, and I had a negative, you can have the same ranges, but you cannot have the same domains. So what I mean by that is if I had another point where I came over here and the point was, say this was 4, 2, okay? It has the same range, but you're going over 4 up 2, so you'd be right here. Does it pass the vertical line test? It does. Okay? When you have a line that you go vertically through and it passes through more than 1 point, it is not a function. Okay? So that's why you need to understand that aspect. All right. So drawing graphs. School cafeteria, there are 3 lunch periods at school. So what we're going to do is we're going to draw a graph, make a table showing the number of students for each period. All right, so remember what a table looks like. All right, the tables are, sorry, not a perfect square, okay? All right, that's a table. So what we're doing is, on the tables, is we're going to have your periods. All right, make this thinner. And this is going to be students, okay? All right, so it says on the chart up here, it says during the first period, all right, there are 352 students. During the second period, there are 304. And finally, during the third period, there are 391. Make a table showing the number of students for each of the 3 lunch periods. Here's your table. Okay? Now, determine the domain and range of the function. All right, what's the domain and range? Now, you can do the mapping process, okay? Or you can just use the table that you just created and understand what you're doing. And what you're doing is when you're creating, let's do the mapping, okay? When you're doing the mapping process, remember what we talked about. When you do mapping, all right, this is the domain, this is the range. All right, let me bring in the shape again. So, on the shapes, let's do most of that one. All right, you have your domain and you have your range, okay? So, if you remember what we did, okay? If you remember what we did, we talked about putting in the x and y values, okay? So, you have an x and a y value. So, your x value in this case is what? It's actually your periods. So, this is also the periods. So, your first domain is 1. And what is your range with this? During the 1, the domain is 352. Domain of 2, it is 304. Domain of 3, 391. Okay, now on mapping, you're supposed to draw the arrows so that you understand the relationship to 2. There's your domain and range. Okay, your domain is always going to be the first number in the sequence. The range is always the second. We could graph this out as well. If we were to do a plot, okay? If you do a plot, you'd have 1, 2, 3. So at 1, you'd be way up in the air unless we did the ratio like by 100. So this is 100, and then this was 1. Then what you could do is you'd have your 1 over 352. So you'd put one like a dot like right about here, okay? Then you'd be 2 over 304. So 1, 2, 3, you'd be 1 right about here. And then 3 over would be 391, so you'd be way up there. So knowing that you're plotting them out, is this a function? Yes, it is. But that's the different ways that you can interpret it, okay? Secondly, when you draw graphs, write the data in a set of ordered pairs, then draw a graph. Well, we just did that, right? I drew the graph. The ordered pairs would be 1, 352, 2, 304, and 3, 391, okay? Now, on the notes that I give you in class, I'm not sure how much of this in notes I'll give you because I want to make sure you guys understand, because you can see the example in your books as well, that the data and information given to you, you convert, okay, into a graph. All right, state whether the function is discrete or continuous. So when you put that function in there, was that discrete or was that continuous? It's discrete. Okay, because according to the definition of discrete, if you guys look on page 50 at the top, function that consists of points that are not connected is discrete. Ladies and gentlemen, it is not connected, it's discrete. Okay? We didn't ask you for a flow chart or a continuation. Now, if they ask for a continuation, they label it differently, it's possible. But they don't actually start at 0 and go to 4. It's just a couple points plotted out. All right, guided practice. Then what I want to make sure you guys do is please follow along with this. Look at this. A bird feeder will hold up to 3 quarts of seed. This is on page 50. What I want you guys to do is set up your table. write a graph, and you go from there. All right, this is a big note for you guys, making sure you guys understand something. All right, so let's talk about this, okay? If you guys go on this, when you're doing these examples, just make sure you know a couple different things with this, okay? Can you connect the points? So I want to make sure you guys get an understanding of this, where it goes 0, 2.3, 1, 13, and the 3. Okay? If you plot this out, all right, what you guys would come to understand is on this one, all right, it's asking, can you make it continuous? All right? Is there a continuing function in relation to this? So if I start out and I go 0, 2.3, all right, go out there, let me change the color. If I go 0, 2.3, and then my next point would be 1, so from a graph standpoint, be 0, 2.3, okay? From a graphing standpoint, that is 1 point. The next point would be 1, 6, then you would go 2, 9.7, and then your final point would be 3, 13.4, okay? Now, if I start at 0 and go to 2.3, the next point over would be 1, and then 6, and then you go over again, 2, 9, 7, and then finally you have 3, 13.4. Now, what happens with this, ladies and gentlemen, is when you're going along, if I were to actually connect the dots on this one, okay, does this look like this is a continuous line? The answer to this is yes. Okay, so state your domain and range. Domain 0, 1, 2, 3. That's kind of set up. The range 2.3, 6, 9.7, 13.4. If we were to actually do some math on this, you would actually see that there are consistent value changes within this context. Okay, so what's cool about this is making sure you guys understand how this can actually be construed. Okay, if you were to draw it out, pretty much what you would get, ladies and gentlemen, is a nice continuous example. All right. If you have any questions about this, please let me know. But if I were to plug this into Desmos, which we'll learn about a lot over the next couple weeks, what's cool about Desmos is that you guys would actually see that this is a continuous line. Okay, it doesn't go crazy. All right. Equations as functions. Determine whether x equals -2. Is it a function? All right. X equals -2. So what if every value is x? Is this a function? Ladies and gentlemen, the answer to that is no, it is not a function, because it technically is a vertical line, so it does not pass the vertical line test. Okay? Determine whether 3x plus 2y equals 12 is a function. You guys look at this real quick, and you figure it out, and you tell me what it is. All right, is this a function, ladies and gentlemen? Does it pass the vertical line test? The answer is yes, it does, so it is a function. Okay? All right, concept and summary. So what I want to make sure you guys understand a table, what a table is, what a domain, what the mapping is, what an equation looks like, and what a graph looks like. Okay? Make sure you guys understand what can represent as a function. If I show you a table, all right, not necessarily saying that these are functions, okay, but if I show you a table, if I show you mapping, an equation, or a graph, these are 4 different ways that I can show you a function. If you guys look on page 51, it's at the actual bottom, okay? Just kind of an illustration of what you're doing. Now let's talk about function values and function notation, okay? F of x is actually called a function notation, okay? So what you're doing is you're taking an equation. If you look at the top of page 52, this is saying, basically, it's y equals 3x minus 4. But instead of putting y in there, you're putting a function notation in there, which is called f of x. Which what that means is if you want to find a value, right, of 4, what you're doing is you're taking f of x, or so it's f of 4, equals 3x minus 4. That's how you write it out. And what it's trying to get to you is saying, what is the function, all right, of x? So you take this x value and you plug it into here. So what you get is your f of 4, okay, equals 3 times 4 minus 4. And then you work on your equation. So what is 3 times 4? It is 12. 12 minus 4 equals 8. So what it means is the function of 4 equals 8. Okay? So what that means on a coordinate point is that the first coordinate is 4, and then the value or the answer is 8. Because remember, this is the same thing as saying y equals 8. All right? If you guys have questions about this function notation in class, please raise your hand and we can talk, and I can give you more examples if you want. Okay? Any questions on that, let me know. All right, so that's the end. Look at the illustration on 52 at the top. It'll kind of give you guys a great example and kind of walk you through a couple other examples. So let's talk about this one. Remember, instead of, you're trying to find what the y value is, okay? But we want to find the function of this, and then we want to add 6. All right, so let's write this out. So the f of -5, okay, equals this function, which is 3 times -5 minus 4 plus 6. Okay, we're adding 6 at the end. We're taking the function, we're trying to find out what this number is, and then we're going to add 6 to it. So let's work on this. Remember, PEMDAS, order of operations, is multiplication first. 3 times -15 is negative, or 3 times -5 is -15. Minus 4 plus 6. Work left to right. These are two negatives. Negative and a negative is still a negative because you're adding it together. So it's -19 plus 6. Add that in together. You get -13. There's your function. Okay? If you guys have any questions on that, please let me know and we can talk about it in class. So what I want you guys to do now on your own, look at the guided practice. I want you to do 2 of these, please. I would prefer you guys to try these 2 right here. Okay, try to see if you can do those on your own, and then what we'll do is we'll cover them right now in class. All right, if you guys could do these 2, because these ones are relatively simple, you just plug the values in, you can get it done. But these are more difficult. So what you want to do is take the value of 5, okay? So we're going to take the value of 5. So on this one here, it's going to be 6 minus, and then we're going to plug in 5 into this value. So it would be 2 times 5 minus 3. Okay, that's how you set it up. Do your PEMDAS, multiplication first, okay? So what you gotta do is make sure that you understand that we can put brackets around that because that's its own internal value. And so we have 10 minus 3 minus 6. Subtract that out, you get 7. So you have 6 minus 7, which equals -1. Okay, that's 1. All right, now the reason you guys make sure you annotate it like this and you put brackets around it is because you're trying to you basically have to understand that you're taking this piece of the equation, all right, and you're plugging this piece of the equation into here, all right? So everything inside this is going to be negative, all right? If you guys are struggling with this concept, please come see me and I can give you more examples and we'll go from there. Now this is the same thing, okay? So what you're doing is you're taking this value and you're plugging it into here. But instead, you're going to have 2 times -1, all right, minus 3. Associative property, and then you put plus f of 2. So I plug a 2 in here. So it would be 2 times 2 minus 3. All right, that's your setup. Now, what you're doing from there, ladies and gentlemen, is pretty simple. Now you do your PEMDAS operations, okay? So 2 times a -1 would be -2 minus 3. Okay, plus 2 times a -3 is what? Or I'm sorry, that one's backwards. So this is -2 because the order of operations is minus 3. All right, sorry, I got my symbols confused. 2 times 2 is 4 minus 3. Okay, so that's your setup. Now you just solve, right? So -2 and a minus 3 is still a -5. And then 4 minus 3 is +1, so your answer is -4, okay? Please make sure you guys understand how to do that, all right? If you're struggling with this, we'll have plenty of opportunity in class. Kind of let me know, because like I said, this is a 2-day lesson, okay? I want to make sure you guys get it. So that's how you do these operations, all right? Hopefully you'll get it. If not, let me know. So this, a nonlinear function. all you're doing is find h of 3. Okay, so if you have h of t, what it means is you're taking all these t's and you're replacing them with what? 3's. So you just bring this down. 1248 minus 160 times 3. Now what I need to start doing, and what you guys should do at home, is kind of put brackets around it. Makes it easier to solve. Plus 16 times 3 squared. Okay? Because what you want to do is focus on it piece by piece. If you put the brackets around it, it makes it kind of separate things out so you don't get so confused. Okay? So what I need to do is let me break out my calculator. Make sure I know I get these numbers right. All right. So what you have is 160 times 3. 160 times 3 is 480. So your next setup would be 1248 minus 480 plus, so we know 3 squared is 9, so it would be 16 times 9 equals 144. Okay? Put in the calculator, ladies and gentlemen. 1248 minus 480 plus 144 equals 912. Do I expect you guys to do this in your head? No, not at all. What I want to make sure you guys do is, what we're going to teach you this year, 93% of everything that you learn can be done via a calculator. My goal, ladies and gentlemen, is to help give you the critical thinking skills to go beyond a calculator and go beyond simple equations. That is it. Okay? Understand what you're doing here. Now, h of t, same thing. Okay? Now, complication is now they give you another variable, 2z. How nice of them. So instead of, you're going to take all the t's and you're going to replace it with 2z. So 1248 minus, put a bracket, 160 times 2z plus another bracket, 16 times, and this is going to get slightly complicated, 2z squared, close the bracket. Okay? That's how you should write that one out, because you need to understand what you're doing to each order of operations. Now, what's ironic is that we haven't learned some of the exponents parts, but I'll teach you that right now, kind of on the cusp, okay? 1248, can you do anything to that? Nope, it's not going to change. All right, minus, what is 160 squared? Is actually 320, is that right? Make sure I'm not, times 2, not squared, times 2, yep, 320. 320z plus 2 squared and z squared. So what is 2 squared? 2 squared is 4. So it would be 4 times 16, which is 64, z squared. How about that? All right, it's nice they give you this kind of stuff right now. If you guys have any questions on this, please, like I said, ask me in class. I'll be more than happy to do it. If you guys look at your examples, all right, if you guys look at letter B, it kind of gives you an example of what to do with those functions, okay? They have h of g, they plug it in, you kind of see how they did it, and we did the exact same philosophy and principles behind it. Now your guided practice, what I want to make sure you guys can do is please cover these up, okay? See if you can do these. Focus on the B and the D if you can. All right, if you guys can get those done, that would be great. All right, so what you're doing is basically you're taking this f of t, okay, and you're going to throw this function into here, and then you're going to multiply it out. All right, so what you're doing is, since this is t, and the value here doesn't really change, what's ironic is that this basically becomes, so it would be 3 times the t function, which is just t squared, 2t to the third plus 2. So the answer to this is 6t to the third plus 2. All right. This one here, ladies and gentlemen, if you were to plug a 4, so remember, you replace it. So f to the fourth would be 2 times 4 cubed. All right. That is 4 times 4 is 16 times another 4, I believe, is 64. Okay, so it'd be 2 times 64, and that will come out to be 128. Okay, 12. Yep, sweet. All right, that's the answer to that. If you plug in a -5, okay, what's cool about this is we haven't really talked about this much. All right, if I plug in a -5 here, -5 times -5 is what? 25. 25 times another negative 5 is what? Times negative 125. So the answer to this would be negative 250. Make sure you guys don't get confused on that, okay? Remember what this represents. We haven't really talked about it. It's funny that we're going so far in advance with the exponents, but you know what this means, okay? This means negative 5 times negative 5 times negative 5. If you guys can see this and translate it into this, then you'll get the correct answer, okay? Knowing that negative times a negative is positive, but they multiply it again, it's a negative. And then lastly, if you plug in the negative 3's here and the 1, you'll be able to figure it out and multiply it from there. Ladies and gentlemen, that is it for this long lesson. Hope you guys learned a lot. We covered a lot with this scientific notation. We'll be doing a lot more stuff like this with the function notation as we move along. Just know that this is the beginning. If you're struggling, it's okay. I'm here to help you. Come see me, watch the video again, or we'll be able to do Alex or some more interactive stuff hopefully online soon. In the meantime, have a great day.